let's imagine that there are two paths. One is the data entry person or
Yeah.
the quote desk person is entering the price or placing a PO or
Yeah.
whatever the action might be. Or there's the alternative version that it is a machine learning algorithm that is saying buy or push, pull, cancel
Yeah.
this PO, whatever is happening. In either of those cases, what we want to do is record in the ERP the source of the decision.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our number one priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at independent ERP and digital transformation consulting firm Elevate IQ. Finding the right system for the right job is more difficult than you would think. Most companies end up mixing the boundaries of the systems. While the journey of data science could be powerful, it's hard to get meaningful insights that'll be actionable and drive business outcomes with data silos. So, what do companies need to do to get results from their data science initiatives? In today's episode, our guest, Tony Ogg, discusses the first steps enterprises need to take for their data science journey. He also discusses the architectural differences between the data science systems and operational systems. Finally, he discusses the budget planning for the data science projects and how to be successful with them. Let me introduce Tony to you. Tony Ogg is the COO and co-founder of Nimble Gravity, a strategy, digital, and data science consultancy. He was previously the vice president of R&D and CTO of digital for Aero Electronics, a global technology company where he was responsible for research, engineering, product development, and big data analytics. An electronics industry veteran, Tony has also held a number of engineering, supply chain, and IT leadership roles at Sanmina, a leading electronic manufacturing services company. In 2009, Tony co-founded Timzon, now Snap Engage, a live chat software company, and a graduate of the Techstars Startup Accelerator program, and he applies those experience as an investor in and advisor to several early stage startups. With that, let's get to the conversation. Hey Tony, welcome to the show.
Thank you. Thanks for having me.
Of course, it's my pleasure, and anybody who comes from data world is always going to be super fascinating because the kind of stories that you're going to have, they are always mind-blowing. So just to kick things off, do you want to start with your quick intro and current focus?
Yeah, sure, Sam. So I'm Tony Ogg. I'm heading up a strategy, digital, and data science consulting company called Nimble Gravity.
Yeah.
And we're looking forward to the conversation.
Okay, amazing. And obviously, we are going to be discussing and digging deeper into your work experiences as well as the consulting engagements that you have done. But before we do that, we have one of these standard questions that we ask every single guest, and that is going to be, Tony, your perspective on business growth.
Yeah, I think assuming growth is the target of most businesses, I think that what we like to think about is how to enable that in a data-driven way, and not just from a data perspective, but in a highly attributable data perspective. In other words, in tying decision making directly to data, so that you can look at the work you've done around data and determine that was part of or entirely the reason why the growth happened.
Yeah, could not agree more. I mean, everybody understands the importance of data, and the more information that you're going to have, obviously, you can be more informed with your decision. I'll tell you my perspective, and I have my own philosophy in terms of what works and what I have personally seen. You obviously you can counter, as you like. So from my perspective, obviously data is important. There is no question. But we have also seen that you can paint any story. Okay, literally any story based on data. So sometimes the whole notion of data is emphasized, but in our experience the quality of data matters a lot. Okay, the ability to be able to interpret the data and really draw the conclusions that are going to be meaningful and that are going to be the real story that the data is telling, which is typically buried under the data. And obviously it varies based on the customer segments as well as the industry that you might be targeting. So maybe you share your experience, and if you have any sort of stories, obviously those are going to be probably the most meaningful. So you share what you think, from the data perspective when you are consulting in your engagements.
Wow, there was a lot there, Sam. I
Yeah.
think when I consider data, I think there's kind of the volume of data,
Yeah.
which is you've heard, I'm sure in data science, this sort of concept of three V's: variety, volume, and veracity of data,
Yeah.
or velocity, depending on who you talk to.
Yeah.
I think when I think about the topics you just brought up, one is you need to be really intellectually honest with yourself around data.
Yeah.
So I think there's this concept that says, hey, I want proof of X within my business.
Yeah.
And X could be something like that our strategy around e-commerce is changing, or our strategy around purchasing is having a good impact. And it's probably possible to find some data somewhere within your data lake or data warehouse that
Yeah.
backs up what you want it to back up. And I think there's this selective concept around data that says,
Yeah.
well, if you stop there, you may be faced with this opportunity to make a very bad decision,
Yeah.
and everything looks great. And if you ignore the what else is happening, you can probably end up in not a great place. So I would say number one is intellectual honesty around what you're seeing in the data,
Yeah.
understanding what's an outlier and what's not an outlier. And then finally, I would say, ask the data questions other than the one that you got asked by your COO or CFO, and let that guide where you go. And that's maybe the one of the primary differences I would say between a data science type workflow and a reporting business intelligence type workflow, is pull those threads and see where that might take you.
Yeah, so very interesting perspective, and I'm simply going to build on whatever you said, and I may ask some of the clarifications, for our listeners, because they might not have as much background in things as we may have. For example, let's say you mentioned three V's, and my audience is the CFOs, CEO, so they might not be familiar with, okay, what are those three V's? So you mentioned the volume and the veracity. I guess that's the truth of the data, and I don't know which was the other one.
Yeah. The typical ones, Sam, are volume, velocity, and variety, and those are kind of differentiation between what is old-fashioned data and what would be big data or data science. That concept of really huge data, hence the concept of big data, how quickly it's updated, and then the combination of different data sources. So that if I was to make it really concrete for a CFO, the idea would be around volume. This could be something like uh, you know 5 years or 10 years of history of quotations or AR AP data within your ERP, something like this.
Yeah.
Around the velocity, this would be, instead of looking at things in a quarterly fashion, running a report, or maybe even monthly fashion, this would be more or less real time or daily, something like this.
Yeah.
And the idea of it there being like, it's great to know what already happened in the rearview mirror,
Yeah.
kind of thing. And then the third one would be variety, and that could be something like combining your ERP data with maybe customer service data or CRM data or shop floor quality control data, or any other thing to say, can we find some pattern relationship between what's happening in two different systems? So those would be some examples of the typical 3Vs that you might hear around big data.
Okay, so very interesting. Now let's talk about a business, and obviously our intent of this conversation was more of, okay, how do we start with this whole data journey, and whether we are going to get any sort of ROI from that or not, right? So number one pillar in your conversation is really the volume, right? You are mentioning, and you have clearly painted the picture that volume means, okay, can we get 5 years worth of data from the quotes perspective, from the order perspective? But at the same time, let's say if I'm a $5 million now, and even if I go 5 years back, I probably know each of the customers by their last name. I probably know each of the orders that they have placed. So now in this particular business, am I really going to get enough value? Let's say if I invested in a data science project versus, let's say if I'm looking at Fortune 100, Fortune 500, obviously for them, they just don't know anything about us. Okay. They just know the stories that their VPs are telling them, and it just because the massive workload and the data and the information that they have. So for them, data science is going to be far more. So now, in your experience, where do you sort of draw the boundary in terms of who should be using the data science, who should not be using?
That's a great question, Sam. I think in smaller businesses, the question really is, what is the number of transactions? That's probably how I would think about that.
Yeah.
And so if you're a $5 million business and you have a single transaction a year for $5 million, your ability to predict what's happening and what's not happening is you should get a quarter and flip it, maybe.
Exactly.
I'm joking, of course, but
yep.
I would say part of it is transaction volume, and thinking about this in thousands or tens of thousands is probably the right ballpark to think about it.
Yeah.
And then think about how many different variables you may want to test against those different 10,000 outcomes or 20,000 outcomes. So if there are 1,000 products and you sell one per year, you probably aren't going to have enough data to understand what's happening. If you have a single product and you're selling it in a pretty consistent way, you may be able to benefit from a machine learning model. So the example I would give you is, if in a $5 million business you have a quotation and you're getting 100 quotations a day, understanding which quotations convert to an order and which do not is probably a really nice opportunity for a machine learning model to understand which quotes are coming in the door or coming through the website or however they're coming, which of those are you likely to win and which of those are you likely to lose. And that's going to tell you where do you maybe want to spend some time sharpening your pencil, or which orders maybe can you increase the margin a little bit, or which quotations you might want to return faster in the event that speed of response is one of those things that results in a higher win ratio on those. So those, just one specific example on that. I would also just say, like, in this journey, the first thing is instrument and measure and record the data somewhere. So the good news is, if you're using some sort of cloud-based systems for your ERP, you probably already have this because the vendor that's providing you with the software is doing this for you. If you're doing it on-prem, hopefully you have backups, or somebody is keeping copies of these things. That's the first thing. And the more you can sort of keep that in a consistent, clean fashion, the better, because that's going to help you understand what's happening. And then probably you're using a tool like Excel or Power BI or Tableau or something like this, though, to visualize in the rearview mirror what happened in the past. And if you're in that part of the journey and starting to get a view visually, or dashboards, or these types of things, you're probably close to being ready to start thinking about how to take that rearview version of history and start projecting out into the future of what might happen in the future.
Okay, so amazing insights there. I absolutely love it, the way you have put it there. So now, one of the things that I am always thinking, and typically, most of our engagements, Tony, are going to be, okay, how can we define that architecture and the clarity of different systems that we are going to have inside the enterprise architecture? And I don't know how deeply you get involved with the different systems, because obviously you need to make decisions. Okay, whichever technology systems that you are bringing in the fold, they need to have the right role, they need to have the right interaction and the collaboration model with the other systems that we have in the architecture. So when we talk to a lot of people, okay, obviously there is a lot of noise, and we all know that the maturity of understanding of different technology and the role that they play in an organization is just poor in general. Okay, so we see scenarios such as, okay, I am going to build this data lake, I am going to build this data warehouse, and I am going to be processing my transactions, for example, cutting POs inside my data lake. And I'm like, okay, what the hell is going on here? Because now, we need to set the clear boundary. Okay, there is a study phase. The study has its own importance and meaning, and what information that can feed to your operation system and what results you might expect from that. But that is not to say that you can process your transactions inside your data lake. And so, do you see similar scenarios in your space? I mean, where the architecture is all over the place, and sometimes they are doing crazy things, and because of that, obviously, they don't get results and complain, I guess.
Yeah, it's definitely something that relates to the maturity of the overall architecture of the company. So I would say, in this journey,
Yeah.
one of the fallacies would be that you need to jump directly to data lakes and Hadoop clusters and all these fancy expensive things, and you need to hire data scientists. Like, ultimately, there's a version of this that says, I want to see if there's a there, if there is signal in my data. And
Right.
at the very, very simplest version of that could be, I'm going to look at 50 columns and 10,000 rows in Excel and do a simple linear regression or regression analysis on that to say, do any of these 50 columns have something to do with the outcome? Did I win the quote? Did I lose the quote? Did I get the PO? Whatever it is. And based on that, then you can decide, do I want to take the next step in the journey, or the next step, or the next step? And those would typically be something like using some cloud-based architecture for a data lake. And the concept of a data lake is, I don't know what data here is ever going to be useful, but if I don't collect it now, I may regret not having it when I think it's going to be useful. And all the rivers, if in the metaphor, are ending up in a lake, and that's fine. And then you're taking data out of the lake to some sort of data warehouse or cleaned up systems for use. And in your case of, am I processing something outside? Like, I would say you have a system of record that should be the system of record. And so let's take an ERP. ERP is a system of record. It is the financial system of record. It's the purchasing system of record. It's probably the customer master system of record, or something like that. In an architectural relationship, though, you can think about, there are things that the ERP is interacting with a human for. Something like, what should be the price that we quote the customer? I'm using this as an example. Think about, in one way to think about this is, how do I start to make better, faster, more informed decisions in that capacity, where instead of it being a human entering that this order is $18, that we have built an API on top of a data science environment, and the ERP is saying, how much should this order be? And that API is responding with $17.45 or something like this. Or, Sam, the other option might be something like, in my ERP, I'm looking at a quote. Next to the quote, I've added a custom field, or what, depending on the ERP, that's saying likelihood of winning this order. And that column, or that field, is being filled out by a machine learning algorithm that is saying the likelihood of you winning this order is 80%, or something like this, which is this external call with the response back. That's generally the pattern that we see, versus trying to replace a system of record with another system of record. Outside, that gets incredibly messy, and you have master data all over the place, and things that become very difficult. And the last thing I would say, in all of what I just said, let's imagine that there are two paths. One is the data entry person or
Yeah.
the quote desk person is entering the price or placing a PO or
Yeah.
whatever the action might be. Or there's the alternative version that it is a machine learning algorithm that is saying buy or push, pull, cancel
Yeah.
this PO, whatever's happening.
Yeah.
In either of those cases, what we want to do is record in the ERP
Yeah.
the source of the decision. And that way, later on, when we're inspecting what happened, we can
Yeah.
decide who's winning. Is it the people are winning or is the machine winning? Or maybe we make a decision
Exactly.
about moving more to the machine or, doing something like that. So I know I just said a lot, but that's roughly the way I would start to think about that architectural journey.
Yeah, that's awesome, by the way. Missy, you are clearly laying out in terms of what should be the roles and responsibilities of the algorithm versus, where human element is going to be there. And they each have a role to play in my mind. Okay. Everything has a role to play. The problem always is going to be in understanding, okay, where are the process boundaries of the humans versus machines? And again, you need both of them. So I absolutely love your example where you are saying, you know what, I am going to create this field on a code, and that is going to help you in determining the forecasting accuracy. And by the way, when you are going to forecast, let's say based on your own experiences, typically you are going to be looking at, okay, what is happening in the account? How's my customer reacting? Whether they have a real need? Does it relate with my experiences from the past? So obviously, you have this algo in your head that you are trying to process, and based on that, you are trying to come up with a model, and that is going to tell you that whether this is going to close and whether I should be investing my time in or not. Now, when I look at your other commentary, overall from the sales history perspective, typically when you look at the system of record is the term that you are using. You can call them transactional system, operational system, whatever you want to call. But these are the systems that are processing your transactions. And typically, these systems are going to be notorious. Okay. And I'm going to use that word, notorious, in getting the historical. Okay. Each time you are going to be changing your ERP system, for the love of God, do not enter the historical data in the ERP system because that is just too expensive. Okay. So that's where I see the role of your data science data lake, that, okay, this is your balance sheet. Okay. Your ERP is supposed to be your income statement. Okay. That is going to give you the picture of, let's say, 2 years, 3 years, 5 years. But this is your rolling model. And by the way, you also mentioned that, you know what, you can get the external feed as part of the your data lake, where it's not just the ERP data. You might have 15 other systems, and you are probably going to be using more than 5, 6, and then you have the external data as well. So that's where I see the value. So I don't know if you are going to have any sort of follow-up commentary there based on my comments.
Yeah, I think, the other thing that I would say is, in my experience, it's pretty rare to find an organization, even mid-sized organizations, that entirely run on only one ERP system.
Yeah.
And, whether that's through acquisition or you have the one special division that needs its own system or, whatever that is, you often find these cases where you cannot have everything in one ginormous ERP system. And instead, what you do is you say, okay, we're going to get common view on
Yeah.
everything that we're doing in a data warehouse, in a data lake, some other system outside, so that you can run the how did we do everywhere in the world at one time. This is probably not where, by the way, you're doing your roll-up financial reporting for the SEC or whatever. Like, you
Yeah.
probably don't want to do that, but from a where is all my inventory, these types of things, I think that's a pretty common pattern. I would also say, like, this is a little bit of a current situation
Yeah.
today. Imagine that you have 3 different ERP systems running different factories around the world. It
Yeah.
may be that you have excess supply in one factory on one ERP, and you have a demand or a shortage for that exact same product somewhere else. Unless you can combine all of your supply and demand into a single layer across all 3 or n number of different ERP systems, you're not going to understand if I can do that internal transfer of inventory and solve the excess problem and the shortage problem pan system without that. So there are incremental benefits of driving that sort of thing from, a balance sheet or other benefit.
So that's a great example, but I am going to provide my perspective in terms of the challenges that I can see in that model. Okay.
Yeah, yeah,
So typically data science in my mind is this augments processes. Obviously, ERP systems are good at certain things. Okay. They are not good at everything. So for example, when you talk about balancing the supply and demand, okay, and building that MRP algorithm, that is very tight overall in terms of your operation. If you are going to keep anything related to inventory outside of your system, I understand your perspective that when you are going to have three different systems, three different ERP systems, the supply and demand is not connected. And that's why you are proposing that, I'm going to get all of this data in a data science and data lake. And then I am going to be recommending, okay, how much to buy, how much to, build, etc. But that's where I think the boundaries are going to be slightly crossed overall in terms of the role of data science versus where the ERP system should be playing. So in this particular case, if they have the cross-functional workflows, because this impacts your financial directly, right? So that should reside inside they should probably consolidating. If they have this where they need to combine the supply and demand, they should be doing that as part of the operational core. But at the same time, let's say if you're looking for slightly more historical analysis and you are trying to draw the trends and patterns. For example, let's say if you're calculating safety stock, okay, safety stock is one calculation that ERP systems are terrible at doing. Okay, because that requires a lot more layers of data that you are not going to find inside ERP. Sometimes that's going to be external, so that's where I see the real value of data science, and some of the SNOP systems. If you look at them, they typically do that. So now I don't know if you're going to agree, disagree. Please tell me your perspective. What do you think?
Yeah. I generally I agree. I think the actual what is a shortage or what is excess, obviously that has to reside somewhere that's maintaining the inventory and is your primary system of records. However, predicting when you're going to have a shortage and why is probably something that an ERP system wasn't born to do, if you will. And so understanding, the simple examples I would give you are something like, what is the relationship between traffic to your website and the product pages on your website and demand? Is it unrelated? Is it completely related? Are they exactly the same thing? That's one example. Or the other example would be, how many different salespeople are trying to sell a product?
Yeah.
What does that mean? How does it work? So, I think when I think about those types of things, it's difficult. Yeah, to your safety stock example, the ERP is great at executing safety stock, maybe not so great at calculating what it should be. And I would say the other scenario would be, so let's say hypothetically that I have two ERPs, one with excess for the exact same SKU as one where I have a demand.
Yeah.
There are reasons why you might not be able to move that. It may be that you've already committed it to a customer. It may be that there's some weird export compliance thing. Who knows? The understanding of all the reasons why you may or may not be able to ship SKU A from factory X to factory Y or something like this. Sometimes machine learning is really good at picking up what actually happened, and it's not the system that's going to tell you whether or not the financial transaction happened, but it's the one that's going to say it's unlikely that this has happened, or it's super likely that it's going to be able to happen. So there are some of these where I say I think you need to have a hard and fast line around where you're actually committing financial transactions or inventory transactions, whether from a financial perspective. However, the controls and measurements and understanding what's happening, it's difficult to do that inside of an ERP or even an SNOP sort of process. I think those are the types of things. And then I would also just say, like, there's this whole world outside of this that is the what if scenarios and scenario planning and these types of things that are hey, if I change the mix or I cut in this engineering change order, what's going to happen? Well, some of that is the pure, how does the bill of materials flow through and what happens with this, but some of it is also like, hey, what happened in history, the last 20 ECOs that we tried to get it. And some of those become a little more subtle in terms of how you might want to think about those types.
Exactly. And honestly speaking, I think I am going to provide a little example here in terms of,
Great.
painting this picture for our listeners. Because again, it becomes very difficult in analyzing, okay, what should reside inside ERP versus what should reside inside your data science. So let's take a very simple example of a football. Typically, when you have the football field, when you have the real play, okay, real play is not about analyzing things. Real play is about playing. Okay, you are supposed to play because you have analyzed everything and then you are going to the field. Sure, you can take breaks in between and you can, pivot and you can analyze, okay, what is happening in the field and is it consistent with the understanding that I had when I started this play, right? So typically the role of the coaches and the people who are sitting in the background, they are mining a lot of data and coming up with the different decisions the way the game is approaching. But when it comes to the real play, the players are playing, they are not necessarily analyzing because your brain can do one thing at a time. Okay. Either it can execute or it can analyze. Okay. So that's how I like to sort of differentiate between what is your operational transaction versus what's the study analysis. Both of them are important. They have a role to play in the architecture, but the clarity and the fine line between these two is where most people. So I don't know if you're going to have any sort of follow up commentary, agreement, disagreements there.
Yeah, I love the analogy there, Sam. I think that's a great one. I think if I approach football, and I'm using the global version of football
Yeah,
here
yeah.
instead of the American one.
It
If
doesn't
I
matter.
approach that, I would say, like, first, what are we tracking
Exactly.
about what's happening? So one version of that is I have all the players wearing a small device that's tracking their heart rate and
Yeah.
their motion and their position on the field. Another version of that is the equipment manager saying, I issued Mr. Messi this particular type of boot, and what was he wearing during the game?
Yeah.
Because maybe the performance of the boot, and did I go measure the grass on the pitch? Was it very high grass? Well, how many millimeters was it? So all of these things become potentially interesting in understanding what the outcome of the game is. There's also a whole version that says, am I playing at home or am
Yeah.
I not playing at home? What is, how influenceable are the refs? And on November 20th, we're going to start to see some of these
Yeah.
very fancy predictive model. So I would say there is this scenario in kind of in and the American football version is that you have some communication every play,
Yeah.
and so you have a little break. You can make a decision.
Yeah.
There's often the people are wearing something on their arm. They have a earplug. So you have this much more real time thing versus all the preparation needs to happen in two halves of the match, and it's very hard during European football to go, or sorry, global football. So I would come back to the make sure you're instrumenting what you think will matter later on. Whether you use it or not is partially a decision of whether you find signal in that, and then how do you relate that to the people playing the game? So in this case, it's the buyer, it's the planner, it's the master scheduler, whoever that is.
Yeah.
And can you make small indications to them that are going to help them do their job better, faster, more efficiently, whatever that is? Now, sure, from an analogy perspective, it starts to lose its benefit at some point, but yeah, I think of it in sort of that framework.
Yeah, so that's very interesting. So let's talk about the technical steps overall. Let's say, I don't know if you are able to provide a little example there in terms of the overall spend that you are seeing from different companies. For example, let's say if anybody is trying to get into this data analytics realm, and for them, I don't know how much they should be allocating. So, for example, let's say they have an ERP system, may have any maybe POS, depending upon if they have brick and mortar. They might have 4 or 5 different systems. Now they are trying to figure out, okay, how can I build this data engine that is going to give me all the insights that I am looking for cross-functionally, cross-system perspective. So let's say if I'm $25 million business, I don't know if it makes sense to invest in the data scientist because obviously I don't have as good margins, I guess, in my business. Okay, but then I get to, let's say, 50 million, 100 million, 250, it's going to be a different story. So in your experience, okay, at what point they should start how much they should be allocating overall in these projects, in your experience?
Yeah, there's a big asterisk there, depending on the type of business and the
Obviously,
margins and all
always.
these sorts of things. I would say step one is go capture the data in a database somewhere, and it could be relatively inexpensive Microsoft SQL Server or MySQL. Just start capturing the data, and I find probably 25 million is you've already got that type of infrastructure in place. You probably have some reports on top of that you're using every week or every day to understand and manage your business. That's step one. And if you haven't done that, that's probably step zero in this journey is just have the data somewhere.
Yeah.
Step two in this is go determine whether or not the data is clean enough and big enough or of enough volume to start finding some patterns. And so from that perspective is called exploratory data analysis. Go look at the data. Go say, do I have a lot of weird anomalies? Do I have a lot of strange outliers? Do I have 1,000 different transaction types where it will be impossible for anyone to ever understand what this is? Do I have clean and consistent reason codes in whatever the thing is, or do I have a free text field where people can type whatever they want, and it would be very difficult to understand what's happening? So I would say that's probably there are companies that can help you determine, do you have enough there? You don't have to jump to hiring somebody permanently on your staff to go figure that out. And that's probably like a month-long or 6-week-long effort to go say, hey, for a given use case, let's say quotations, do I have enough data that is of a consistency and cleanliness that helps me determine the signal to quotations or to pricing or something like that? If you do, then it becomes a little more challenging if you think of data to information to insight to action, the action part is probably the most difficult.
Yeah.
The scenario of, can I build a machine learning model that is relatively predictive of some outcome? Great. The harder that's not to trivialize it, but often that's the easiest part. The harder part is, how do I go actually implement this into a production system? So if I'm talking about, placing a purchase order, that's a little bit of a thought exercise to overcome of, well, is there a portion of purchase orders that I feel comfortable placing automatically by a machine? So often you set rules in your ERP system that say, if these are satisfied, go ahead and place the PO.
Yeah.
In these other cases, go look at what the person did.
Yeah.
Look at the inputs and say, oh, in this percentage of cases, a machine learning algorithm is 100% confident or 99% confident that we should place a new PO. Great. Well, what do you do with that? Do you let the machine do it, or do you surface that to a user to say, go, go, go? And how do you make sure that people are confident that the machine can't go out of control and suddenly you've spent millions of dollars on things that you don't need? So I think that part of the journey is probably more of a traditional IT relationship of how do you implement this? How do you otherwise it's this thing that you look at over on the side and say, oh, great, we could predict that we should place all these purchase orders, but until you actually implement that, you're not getting the benefit of it or doing that. And that's less of in my experience, less of a data science activity than it's whoever is managing and maintaining your ERP or whatever.
Yeah, could not agree more. So that's it for today. Do you have any last minute closing advice for our listeners?
Yeah, I would say the first thing is back to the intellectual honesty about the data. So I think about these patterns and trends that you see when you're looking at your dashboards, when you're looking at your reports, and ask yourself the question of, like, do I understand why these are going up and down? Do I think that the campaign we ran or the new training we did or whatever it is that what's actually attributable or driving that change? And think about ways that you can know that.
Yeah.
That's one. Think about the things that you wish you could automate that maybe haven't traditionally been automatable within your own business, and whether or not the power of machine learning could do that. And then the third part is think about new starts, if you were to start the company over tomorrow, would you do it the same way, or are there opportunities for a more data-driven approach to create a competitive advantage or differentiation in whatever particular space you're in? I think those are the things that I would say in this.
Yeah, could not agree more. And my personal takeaway from this conversation is going to be there's a lot there overall in terms of the. So make sure you really understand, what you are getting out of it and use it, and then it will feel far more meaningful than simply just randomly going after the data science. On that note, I really want to thank you for your time, Tony. This has been a powerful episode.
Thanks for having me. Thanks, Sam.
My pleasure. I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully you learned something new today. If you would like to learn more about Tony or Nimble Gravity, head over to nimblegravity.com. It's nimblegravity.com. Links and more information will also be available in the show notes. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform or DM me on any social channels. I'll try my best to respond personally and make sure you get help. Thank you, and I hope to get you on the next episode of the WBS Podcast.
Thank you for listening to another episode of the WBS Podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.